Alright. For this is solving for molarity. So as we know, molarity equals moles over the volume, which is in liters. So the first one's basically a solved for, so it's M equals 1.457 mole over 1.5 liters, which equals the answer of 0.97 mole. B, you need to convert this gram into mole, and then that's it. So you start off with 0.515 grams of H2SO4, which is hydrogen sulfate. You times that by 1 mole over the weight of this, which is 98 grams. That way we get rid of grams, which equals approximately 0.09 mole. Therefore, since you have the liters already, polarity equals 0.09 over 1, which equals 5.25 times 10 to the negative 3 moles, or molarity. C, turn this into mole and turns this into liters. So first step is 20.54 grams of aluminum nitrite times 1 mole over the amount of weight, which is about 220, which equals approximately, oh, okay, sorry. This one is wrong. This one actually equals 5.25 times 10 to the negative 3. Alright, C is 0.09 mole, and the second step is 1575, and for every 1 liter, there's always 1,000 milliliters, so this is basically 1.575 liters. So then you do your molarity for the molarity equals amount of moles, which is 0.09 over 1.575, which equals a molarity of 0.05. D, you need to change your kilograms, which is a different form, and your liters already solved for. So for D, you do 2.76 kilograms, and for every 1 gram, this is a different conversion right here. So for every 1 gram, there's 1,000 kilograms. And then you convert this into the mole, because this gets rid of the kilograms, which leaves you with the gram. And then you times this by the weight of this, because you need the mole. So that's 1 gram over 250 grams, or 1 mole, approximately, which equals 11.1 moles. And then this becomes, and then we have to solve for the molarity, which equals 11.1 over 1.45, which equals about 7.65 molarity. Alright. E is just molarity equals M over V. So then it's just 0.005653 over 10 milliliters, 1 over 10, 1,000 equals approximately 0.01. So this way it equals 0.563 molarity, and then ABC, yeah. So this is 0.0008889 grams of C2H5NO2. You need to get to moles, so you put that over 1 mole, and this substance weighs about 75 grams. If you do the calculation, you get approximately 1.184 times 10 to the negative 5 mole. Then the second part is 1.05 milliliter times 1 liter over 1,000 milliliters, which equals approximately 1.05 times 10 to the negative 3 liters. So then to solve for molarity, it's 1.8184 times 10 to the negative 5 mole over 1.05 times 10 to the negative 3 liter, which equals approximately 0.011 molarity. Okay, that's how you do these ones. So these are done. For this one, let's actually get rid of this because we don't need it. Just ignore this. Okay, it's 1662. Okay. So for this formula, it's usually written down as C1 V1 equals C2 V2, or if it helps you to find because concentration is also molarity. Sometimes it's written out as M1 V1 equals M2 V2. That way, you can tell that M is the concentration because M is molarity. So in this one, I'll be using this. Okay. So if 4.12 liters of a 0.850 molarity of hydrogen phosphate solution is to be just diluted to a volume of 10 liters, what is the concentration? All right. So this equation gives us 3 of the 4 things we need. We have a final volume. We have a starting amount of liters, and we have a starting amount of molarity. So in order to solve, so we have the final volume. So if we have the starting molarity, starting volume, and ending volume, we need to solve for M2. So you just divide this by M2, divide this by M2. So then for the first equation, your equation is M2 equals M1 V1 over M2. Oh, I'm sorry. No, it's V2. V2. You divide this by V2 to get rid of it. Okay. Okay, that's your equation. So M2 is equivalent to your first molarity. I'll just write this in this. This is your first molarity. We don't have a second molarity. You have our first volume. Okay. So, and this M1 equals 0.85. V1 equals 4.12. And then we divide this to get our final one, which is 10.1 liters. If you do that calculation, you get 0.35 M2. Okay. This one, just write the formula out. Alright. What is the concentration of a sodium chloride solution that results when 0.15 liters of a 0.556 molarity solution is allowed to evaporate until the volume is reduced? Okay, so we have the volume. We have V2. So that means we're solving for M2 again. M2 equals V1 V2, or M2, M1 over V2. Okay, so we have M2 is equivalent to 0.105 liters on the bottom, and we have a starting amount of liters, and a certain amount of molarity, if we're putting there. So it'd be 0.150 times 0.556, which equivalent to 80 M2.